I hope my screen is visible.
Yep, looks
Yeah.
good. Yep.
So yeah. So this is my fork of the Buildpacks GitHub Actions, and if we see, like, whenever we release Buildpacks GitHub Actions, whenever we release like 4.2.0, so what we need to do is we also need to manually update right now the registry index of Buildpacks. So I have this fork as well available here. Like, this is my fork of registry index, and this is the Buildpacks registry index fork. So right now it's updated, and where do we update it? We update it here. Like, even this commit was doing the same. So version updated to 4.20. So right now we need to do this manually. Like, whenever the GitHub Actions is released, we have to fix the registry index also, and we need to change it like from 4.1 to 4.2. Everything is done manually. With the project that I have done, which is now working on my folks, and will be hopefully working in the original repos by the next week. What it does is it automates the entire process. And how does it does that? Let's go to my fork of GitHub Actions. So I have created a workflow, and what does that workflow does is, let me open that workflow. So what does this workflow does? So if we see, this is creating the PR. So this is not exactly creating the PR, but it is actually dispatching an event that is being triggered here. So what is triggering this workflow? This is being triggered on release, because we will be using this workflow on release whenever we will be releasing GitHub Actions. So right now in front of all of you, I will be releasing just a dummy GitHub Actions on my fork, and we will see what will happen. So what it is doing, it is disposing uh, an event, and that event is being disposed where? In the repository registry index, that is which belongs to my fork for now. So if you go back to my fork of registry index, and if you look at it right now, the current state of it has a version 4.1.0. So if we look at that like this, so current state is 4.1.0. Now I will be releasing a dummy version 4.2.0, and we will see that how it triggers this repository registry index as soon as we release there, and a pull request will be created here. Right now, there are no pull request, but there will be a pull request that will be created here, and that pull request will automatically be committing an update that will basically update this version. So how it is this happening, I think we will see after the demo itself. So let's move forward to the demo. So right now, this is version 4.10. So I'm creating a new release here, and I will be tagging it with the going with the same semantics 4.2.0, and release title will be 4.2.0, and I will be publishing the release here. So this will trigger an action here. First of all, that action will be uh, creating the PR, this action. So this action will be triggered in GitHub Actions repository. And now another action will, after this, say this action is successfully run. So now there would be another action that would have triggered here on my registry index. As you can see, it is visible. It has been triggered here. So it's all happening automatically. It will now create a pull request here. As we can see, the event, that action has run successfully. Now, if we go to the pull request, we will be having a pull request. Yeah, so we are having a pull request, and this pull request is updating the version automatically. So like I released the version 4.20. So now from 4.10, we can see this is 4.20. So all this is happening, all this has been automated, which was earlier done manually. And sooner we will be creating a PR to both the repositories of Buildpacks registry index and GitHub Actions, which will make it workable for both of them. And how does this happen? Let us try to figure out that. Um, if we will go to the registry, we have seen the workflow there. Here's another workflow added that is in registry index. So what it does is that it waits for that repository dispatch event. So that this is the trigger for it. the trigger for that was release, and the trigger for it is this repository dispatch, and which type I have for now just kept it my event. We will change it to a better name later on, just for testing. And how does what was the logic? So we are using curl to get the latest version. For now, we are getting the latest version of my fork, Mrityunjay Sharma 394 GitHub Actions releases. We may later on get it of Buildpacks when we'll be doing it for the official original repository. And we are using sed, and this logic was greatly helped by Joe himself. So thanks to him, so that he helped me develop this logic, because I was initially not doing in that way. I was also using sed, but it was taking a lot of time to figure out to come up with the best logic. And this does our job pretty easily. This creates the pull request, and if we merge it, then our version will be automatically updated. So that was the demo. And if you have any questions, anything to suggest, then I would love to answer. Thank you so much. It's not
you unmuted yourself, Joe, so you can hear the tiny little claps. Is that?
Thank you. I don't know why the screen is not stopping the share. Let me, I don't know what has happened. It has frozen.
Okay. Oh, wow.
Sorry, go ahead. I think one thing that might have, you went over really quickly, is that the first GitHub action opens an issue, which triggers the second GitHub action, which opens a PR. And that was actually, I think, a really clever solution to what we thought was going to be a difficult problem, where we thought we were just going to go GitHub action to PR, but there's an account issue there. So by opening the PR from the registry action, it just completely solves that. So it was a really, really clever
thank you
way to fix that. Good job.
Thank you so much. Thank you so much. Thank you so much, everyone.
Cool. Awesome. Any more questions, feedback, comments? All right, let's go ahead and move on to the next item. I believe Forrest brought up discussions around build bomb. What's going on?
So this is a follow-up to a Slack conversation that I had in the Pack CLI channel probably 2 or 3 weeks ago. I'll see if I can dig up that thread after this. But essentially, I've been, I along with another engineer, Sophie, I've been working on sort of enhancing Paketta's bill of materials. And we're preparing a talk to give at CF Summit about cloud native build packs and bill of materials. And one of the selling points that we were trying to demonstrate was this distinction between build and launch bill of materials. But after doing some digging and having some conversations with a couple of people, I think Emily and yourself, Javier, and Natalie, we kind of discovered that the bill of materials is only an ephemeral file that exists for a short time while you're actually in the build containers, and then can be passed out in the report toml. However, that's only for platforms that would support that. And then even still, like, you have to like go into the container to pull it out. And I was just kind of surprised by how inaccessible this piece of metadata was. And I was wondering, I guess, firstly, if there's a reason why we should not make it more accessible. And then secondly, I wanted to maybe have a little bit of a discussion about what we could do to make it more accessible and more user grabbable. I don't have a better words for that.
So I guess one of the things I'll throw out there is, I know that one of the possible solutions that was thrown in the conversation was like doing very similar to the runtime bomb, which is just attaching it to labels. I think the idea of labels is something that we've already got in scopes to remove, right? Or in our sites to remove. And so I think the natural next progression for that would be adding it to as a layer on the image. But to put build dependencies, this is now my opinion, right? To put the build bomb in a runtime image seems a little bit of a smell, like an anti-pattern, because you don't want to provide that sort of information in a deliverable artifact. Is again kind of like just my general gist of where I'm coming from. But yeah, I'm open to other things.
So I guess maybe my retort to that would be, I think I agree that making it perhaps a default for what the customer could access is a bad idea and an anti-pattern, because it definitely confuses the idea of what's actually in the image versus what was used to build the image. But I still do think that it has important value, because in a lot, in some cases, the things that were used to build the container or build the artifacts are no longer on that image, but they're still dependencies of that image, right? And sort of not having them in that final running image feels like we're missing out on the opportunity that we have when we do bake these bill of materials directly into the image, which is like it's a receipt attached directly to the image throughout the whole process. I don't know if that's a misconception on my part, but that's how I've sort of viewed it.
Personally, I don't see I think in general, I want to make this information available to end users. We did want to separate it from the launch build materials for clarity, so people don't falsely assume like, oh, why did you put, Maven in my image? I don't want that. It's nice to have the separation. And when we originally had this conversation, the reason we chose not to put it directly in the image was for reproducibility. So it's like if you had like one patch version of a build tool change, but the end artifact that was generated was exactly the same, then you'd have an image with the exact same digest, I think was the idea. We can discuss how much that actually matters to people. I think at the time we made that decision, we were taking that as a very important and desirable thing. I don't know over time whether we've gathered evidence to either support or refute that. I think a lot of times when we asked people whether they cared about build reproducibility, people said yes, but they meant like different things by it.
A third option that came up that I kind of want to throw on here as an idea was to do something very similar to cosign, where you have associated artifacts that are not actually part of the image, but can be retrieved through some sort of association, right? To me, that sounds a little bit better because I don't know, I feel like someone with better security knowledge should come in here and say like, letting your end users, anybody that can pull this app image, know exactly the recipe behind it is probably a bad idea, right? But again, that's not my area of expertise to say that with confidence.
I think it would be dangerous, or it would maybe be more dangerous if someone who hosts the image accidentally hosted the bill of materials to people who were using the application that was behind it. But I don't see a big drawback of when you build an image for distribution, other people are going to use it and potentially run it themselves, for giving them the transparency, like having them be able to understand exactly what they're hosting. That seems like very positive, not very many negatives. So I do like the cosign approach, or like using OCI artifacts, saying when the default when you do a pack build, and then with that publish or after you or publishing into a Docker registry, is to produce two images, one that's has the runtime SBOM on it, and another that's an OCI artifacts type thing like cosign is doing, that just has the bill of materials. That also fits with there are kind of some upstream goals of putting software bill of materials in the in the registry in OCI artifacts format that we could take a look at also. So I do like that. Emily, you brought up reproducibility and whether we need to maintain that. I think the perspective we've always had is make reproducibility possible and as easy as possible for end users to achieve, but you have to have build packs that support reproducible builds in order for that to work. And so I'm definitely, although I think it's important to support reproducibility, if we wanted the default to be both bill of materials go separately on the image, and then there's an easy flag you can pass that's like, actually put the build time one here and the runtime one here, instead in different places in the registry, I would be like, I'm not going to argue against that, if that makes sense. That seems very reasonable to me.
So Cosine recently added support for response from their CLI, and they support both Cyclone DX and SPDX. And that was part of the reason why I've deferred like the movement of the bomb from the label to somewhere on the layer or somewhere else, because I think this happened like last week or in the last 10 days. So it might be nice to just leverage what they already have, because they've also figured out a way to sign that SBOM along with the image. And like, I think they also like took some pointers from like a bunch of other security and supply chain folks to figure out how to best associate like signatures with the SBOM, the image, and all of these things together into like things that work with most Docker registries today, rather than like the OCI artifacts thing that is eventually what they're going to move to. So I think it might be good to just piggyback on that, and when they move to OCI artifacts, we can move as well.
Seems like it might be nice to do it for both build and run bombs, do the same thing in both cases. Whether we decide that that's like a file in the image or this cosine approach. As long as they're separate. And if we think it really is good for them, to be published and travel together, I feel like there's no reason to do two different things.
Do we already have this problem today with like report tunnel, right? In the original design of wanting to have a separate file that platforms can make available.
I think there's like a short-term solution, maybe. Is that what you're kind of getting at, Terrence?
Well, not that it's a short term, just that it shares the same set of like, here's a separate thing that we don't necessarily want baked in the image. That I think that was like one of the original things that kind of came up through this, right? Like PAC does not expose report toml. How do I get access to it? Was like something that came up through PAC. And PAC doesn't have to actually do anything with it, right? Like it's up to the platform. And I think like the cosine thing is potentially a way we can maybe piggyback to expose even like some of the report toml things as artifacts that travel with the image that can get associated with each other that we maybe want to standardize.
Right now, the build bomb is in report toml, right? It's just that PAC isn't copying it out and making it available. I can imagine there still being a use case for report toml. I know the other thing that's in there is manifest size. I don't know if that's like metadata that we need to put in the registry and then fetch again, stuff like that. Like I can imagine using it more for reporting about a particular build in a way that is not long-lived metadata you want to associate with the image.
So basically, sorry, go ahead, Terrence.
There's some stuff I was talking to Natalie about at one point of like, I know on our side for Salesforce, we want a way for Buildpack authors to expose metrics of some kind, or even like exceptions or issues. Right now, there's it's kind of, you got to build it into the platform and figure it out, and there's not a standardized way to kind of get that out of the build. And maybe report toml or something along those lines is a way to kind of get that out.
I could imagine a world where you can get like a whole bundle of reports out. So like Buildpack generated reports plus the lifecycle generated report, which is report toml. And then I think the best the lifecycle can do is make that a file. Like at the end of the day, it's going to be up to platforms what to do with that, because I don't think we want to introduce this as a standard that we attach to the image forever and ever.
Yeah, I think there would be certain things that we do want to export as artifacts, right? Like BOM seems like something that naturally fits into that. But a lot of the other things, yeah, we'll have to determine what makes sense to export out versus just produce and keep ephemeral.
I think something we talked about like in a few office hours ago was like things like detect logs or like profiling the build times or detect times and putting that in like var log somewhere. So like it's not polluting your current workspace, but it's there if you want it. And I guess it could just be cleaned up after a while. So I guess these kind of metrics would make more sense to just stay where like the platform is executing the build, and but I would imagine the build bomb is more important than like the amount of time it took to build the image or like detect logs. Um, so I guess report toml or whatever those reports are could stay at some common log directory, and for pack and these other things should definitely be artifacts that are exported out, whether it's in the image or as separate artifacts in the registry. That depends on how we want to implement it, but they should still exist somewhere.
So to circle back and maybe more directly try to answer some of Forrest's concerns, does it sound like reasonable action items are for the short-term pack to simply allow the exporting of the report.toml file through some additional flag or means, and then more long-term kind of wait to see what happens with cosine and the SBOM to figure out whether or not we want to piggyback on that implementation?
How finalized is cosine's SBOM support? Sam, I think you've looked into that the most.
Since last week, I don't know, seems pretty fresh.
It was introduced 10 days ago, but I think like it was mostly Dan and Nisha who worked on it, on the design at least, and they have at least a final design in mind. I don't know how dynamic or like experimental that design is. It is a pretty complicated one because they also wanted to figure out like signing each of these things together and where to store, like where do you store the signature of the SBOM, and then how do you associate it back with the original signature, the image, etc. So I'll try and find the link to that diagram. It's somewhere here.
I worry about creating our own formats that we don't have to change versus picking one that might change, but I don't have a strong opinion. If it seems like that's the way people are gonna move an ecosystem.
They're also targeting cosine 1.0 by the end of this month, and this is like one of the features that planned out for it. And with 1.0, they're expecting it to be more stable. I don't want to speak for them, but we should just confirm like what kind of stability they're expecting around this.
Yeah, I mean, I think it's definitely worth waiting a month to see where it lands. I think that'd be worthwhile. Because I mean, from what I've gathered, there's no real additional pressure, right, for us to get this information in right now.
No, not at the current moment. But it was definitely just a hole that we found that I wanted to, I guess, surface.
Yeah, makes sense. Cool. Is there anything more here to discuss? Okay.
The issue Natalie linked, is that where to go to follow along for kind of the short-term thing you mentioned, Javier?
Yes.
Without exposing report toml.
And I think Anthony already has a pretty good question there. So just following up on that would be great to more or less set the expectation of what the user workflow is. And it seems like he might be interested in implementing some of that. All right, with that said, let's go ahead and move on to the next item, project descriptor O.2 next steps. Who brought this one up?
I just put this in because we talked about trying to continue this conversation in office hours. But if there's other stuff, I know it can probably take up the whole rest of the time.
That is true. There is nothing else on the agenda. Does anybody else have anything to discuss before we dive into this rabbit hole? All right, I guess, yeah, where do we want to start the project descriptor conversation? Is it still trying to define what we're trying to ship for O.2?
Do we have a link for, I feel like I've seen a view in GitHub where it lists out the issues that we have in 0.2, but I can never find it.
The milestone stuff on spec.
Yeah, I can never find that. Does anybody have a link?
Oh, okay.
Because I was gonna say, yeah, we can definitely like we were saying, we can definitely pull pre-post out of that just to make sure we're all talking about the same thing.
I think this is what you're looking for, Joe. Milestone 16. I paste in chat.
Yeah.
The place where we left off this morning was around, KPack and other platforms being able to read the file, portability of the file, things like that. I think there's logistical stuff for point 2 we could talk about, and then there's like the larger, how portable do we want this to be? What are the goals? Do we need to make other changes? Maybe things past point 2.
Seemed like there was portability, but there was also keeping KPack in sync with changes to the project descriptor. Is that correct?
Tecton was in that discussion, or Steven mentioned Tecton, I think, at the end of kind of our overtime.
Yeah.
Call as well, right?
I guess there are 2 questions, right? There's like the can and should every platform respect every field in there? And then there's the how does the life cycle of changes work when all platforms are not going to be updating synchronously? And I think we've brainstormed in this group like longer term ideas for solving some of those issues. It's like if platforms don't have to respect every field, that can be their decisions. It is an extension spec. And if we provided some sort of translation layer that turned a project toml in whatever the latest version was into a version that was locked to a platform API, then platforms wouldn't have to worry about maintaining sort of a life cycle of changes in project toml. I think both of those solutions would address some of those issues. I'm not sure if there is, like, when we're talking about project descriptor O2, my question is, are we trying to solve these problems before we release O2, or are we trying to solve them after?
Yeah, I guess to me, I thought we were already past that conversation, and it's more of the latter, where it's like, these are all now maybe questions or conversations that we're trying to have for O3, right? Or something that supports the O2 to O3 migration.
Is that everyone else's understanding? I got confused because we were talking about like O2 next steps, right? So like for O2 next steps, do we want to be having this conversation? Or do we want to make these O2 next steps so that O2 is not a bad experience for everybody?
How, like, I definitely want to make upgrading easier for both app developers and platform operators. How is this different from a platform that is behind on lifecycle or some other component and needs to upgrade that, or has builders that don't, that don't have the latest lifecycle?
I think
Is
it's
it really different from that?
It's different because there's no upgradable component that solves it for you, like the life cycle, right? So most of these platforms allow you to sort of dynamically pull in new life cycles without someone having to ship out a new version of the platform. That's sort of like what the whole builder model accomplishes. So for everything else up until Project TOML, the life cycle has been the broker of compatibility. But Project TOML is the first time the platform and the app have a contract with each other. So now if you want to push that same app to multiple platforms, but they're enforcing different versions of the contract, then you might need different versions of the file, or we're putting a lot of work onto platforms to continuously, each and every platform, support multiple schemas of the file.
So I think one of the questions that still doesn't quite fit into my mind is what you're proposing. How does that, or I'll step back and say, so far from the things that we have in the project descriptor, I can't see the platforms not caring about the values in there before it even passes it to the life cycle, right? I brought up in the Slack, like build packs. If the build packs are references to things that the platform has to download, are we saying that the life cycle itself is going to be the thing that downloads the build packs in that case?
I'm proposing like another executable part of the life
Right.
cycle, and all it does is translate a TOML file to a TOML file. It's like you give me a project TOML, and I will give you back a foo TOML.
Project
And you tell
TOML,
me you tell me what platform API you're using, and I'll make sure that you get this data in the format you're used to. So then
So
you choose, the platform chooses when it upgrades the API instead of having to deal with the sprawl of what's in apps.
Shouldn't it be the project descriptor API you're using instead of the platform API you're using?
I think the project descriptor file itself is telling you which project descriptor API it's using. It's translating project descriptor API to platform API. So the platform only needs to deal with one API, and that's the platform API, and not two, which is platform plus project descriptor.
So I've always been in favor of having I thought prepare phase could potentially do this. But I feel like if we agree, I think the bigger thing that we would agree on is that we would push this into a lifecycle phase or binary. At that point, I don't care. Like, you want to have an intermediary format, you want to, like, that's really, I feel like, an implementation team decision beyond that part, right? But the bigger thing that I think we need alignment on is if we intend to push the support of Project TOML down into lifecycle.
What I'm talking about still touches the platform. It's not just a life cycle. It's like the life cycle is translating for you, and then the platform is making a decision about what to do with those values.
So really, it's just a simple translator, right? Like literally, it doesn't have to be a life cycle phase or anything like that. It could be something completely external, third party, which is basically I pass it any project TOML. I can pass it any project TOML format, and I tell it I want the output to be v2, right, or v0.2, and then that's the only thing that I could then parse or worry about. But I don't know that there's a guarantee of lossiness, right, of data, and is that a concern?
I think the description I heard there doesn't exactly match the way I'd view this component. So to me, it's like there needs to be something that's viewed, that's versioned with the lifecycle. That is, when a lifecycle says this lifecycle is platform 03, this component translates into platform 03 API. So like versioned with the lifecycle, right? Probably in the lifecycle repo. And it takes Project Toml, which could have a lot of fields, some environment variables for build packs, right? And just extracts the pieces of that that are needed by the platform and turns it into a really kind of simple, ideally not often changing different TOML file, JSON file, whatever, that the platform then parses. So the platform can understand stuff like build packs without having to keep up with the formatted Project TOML, which may change a lot because it's an interface with an app developer that we're still developing, right? We can have this kind of ugly, unchanging platform API that just extracts platform-specific features provided by this lifecycle binary. But it's important that platforms use that part of the lifecycle. Otherwise, in order to get that information. Otherwise, I mean, I think if a platform kept very careful track of lifecycle versions to make sure that it, translated just right, it could be okay. But I think it's important that.
So the only difference, the only difference that I heard from my description was that instead of the platform saying I wanted in, project descriptor 02 version, it's just saying, I know of this platform API 03, take a project descriptor and give it to me in the format that is now encompassed in the platform 03 spec, right? So you're associating the project descriptor into the platform API.
Yeah. And this way we avoid a situation where if we bump the Project TOML schema version, you don't have to kind of carefully make sure that the platform and the lifecycle are aligned, because they're both going to have to read this file if we don't do this, right? You don't have to make sure they have this it's kind of three-way compatibility contract with the file. It puts everything in the lifecycles domain and then creates another contract with the platform that can change much more slowly. That, if it's ugly, it doesn't really matter because no one's going to see it besides platform authors who are consuming specific fields.
I guess the only downside to this would be some of the performance implications, right, of having to start up a container to execute this binary to just generate this output.
I don't know if it has to run in a container, right? It could even.
It might also be the same container that like sets up some directories and things like that Tecton prepare one. So yes, but in like realistically, you probably need that anyways for some other things would be my guess.
I think in a lot of platforms, it's probably running in a container anyways, if it's a K8-based platform. If you're talking about Pack, where there's a place to run that isn't a container, you could just get the binary. Like, you don't have to start a container.
The lifecycle can include local CLI binaries for common platforms, and then it can be layerized separately, and you could pull them from the image and run them locally if you wanted to really optimize.
I don't. That feels like a slippery slope of like tooling being added to the lifecycle, which I envision as like an engine, right? I don't know. Just seems like all of a sudden we could start adding a whole bunch of stuff just because it's convenient as opposed to architecturally right.
As a platform, like, you're gonna have to create a container to run a build anyways from the builder that has the lifecycle in it. Before you start that container, you can copy a file out of it that's a binary, run it if you want. I guess it's probably compiled for the wrong platform at the point. You might as well just run it in a container. We have so many containers.
Yeah, startup cost, right? In some cases.
If you're doing the creator, you could start the creator container, actually run the binary in the creator container, pause it until it gets the information, and then send it back to the platform. And then there wouldn't be an overhead.
The creator sounds good, but it's been more painful than helpful when we talk about additional, improvements like Buildpacks.
So what you're proposing is basically an IR for project descriptor. Who's consuming this IR?
Could you elaborate on IR?
Like intermediate representation, like like bytecode or like, like common in like compiled languages and things, right? It's like you can change basically the front end part of the language, but at the end of the day, like then you can have this intermediate representation that can then be read and interpreted. I assume it's like a similar, seems like analogous kind of thing we're trying to do here, right? It's like we want to have this IR that doesn't change, where we have the flexibility and freedom to change the like kind of more human facing component of it, from what I understand of what we're talking about. Am I off there? I see
Yes, there's an
Steven
intermediate
somewhat nodding, and then
representation, and the audience for
Yeah.
it is the platform.
Yeah.
so not lifecycle, right? Like it would be like KPack or Pack or the Salesforce platform or
Yeah, if
et
the
cetera.
lifecycle can handle the fields directly, we don't need it. Those are fields that the platform must handle.
So this would just be part of the IRs for the platform API. So we would define in the platform API this IR, but then if a prod descriptor added new fields that needed new fields on the IR, that those would not be supported by the platform. They'd not update the platform API.
Yeah, they'd have to go into a new platform API, and the platform would upgrade to the new API, which is, not so different than what would happen if the platform had to read it directly. It's like you still need to update to pull in new fields, but it would be in lockstep with the platform API. So the platform wouldn't have to deal with a scatter shot of random stuff.
Yeah, and I think that answers Natalie's question she put on the chat. It's basically about why project descriptor 01 to project descriptor 02 is not optimal. I don't know that it's not optimal, might not be the right word to use here, but it's more that it simplifies the usage from a platform's perspective, when now what we're having to think about is going back to a platform API as opposed to a platform API and also a project descriptor API. I don't know if anybody
You
could
can, I mean, the alternative is you basically combine project descriptor into platform API, right?
Then you have a whole bunch of different things that have to meet the same platform API version. Then you're worried about the app, the lifecycle, and the platform keeping track of an API version, as opposed to in this, it's just two components at a time with the different APIs. So there's more careful coordination a platform has to do. Some builders aren't going to work in some cases.
I think it's also that the project TOML is exposed to the user like an app developer, and they might expect changes to be more often, or as opposed to like changes in a platform API. Like if they want like simple features, they would have to wait for their platform to upgrade to a newer API.
I mean, that's already
And again, I think that's
changes the
simplified.
IR table, right?
What?
Sorry.
That's already true if it requires changes to the IR table, right? Like if it requires an update to the platform API to use that set feature, that's already an inherent contract. That is true, right? Like
If the platform is responsible for implementing the feature, no matter how we architect it, people are going to have to wait for the platform to upgrade in order to get the feature, like unless the lifecycle can do it. And what I'm saying is let the lifecycle do anything it can, but the things the platform has to do, let's give them a consistent format for the data.
We can be very additive with that format so that we don't break backwards compatibility in a way that we probably wouldn't want to do with Project TOML, because we want to be able to bump the schema version and iterate quickly on the interface, right? We don't want to have to maintain permanent backwards compatibility for the format. So that's one advantage of the intermediary representation. It's also much fewer fields, right? Because we're just talking about things that a platform cares about. It also gives a platform, it doesn't have to be an intermediary representation in some cases. It could be the lifecycle expressing Buildpacks or builders or whatever to the platform that aren't based on Project TOML. It's just, ensuring that there's only one interface between the platform and running Buildpacks, and that's the platform API. It doesn't have to track multiple interfaces and worry about different versions of the app and different versions of the lifecycle.
So this makes sense, but one of the things that I may find alarming is when you mentioned that it would be like a simplified set of fields, where I know that some platforms may want to add their specific information into that descriptor, right? So I'm assuming that this would still allow for that capability. So like in the reverse domain name concept, right? If you had something under Salesforce, that would still propagate forward into some sort of Salesforce structure in the output.
The
Each
platform
domain,
would read the Salesforce table first, right? And then pass the project TOML in, which, I mean, this proposed
doesn't-
phase would be responsible for parsing the IO Buildpacks table, but other things could be parsed first by the platform.
That doesn't make sense, because then that still requires for the platform to know what the data structure is ahead of
But-
time.
each domain has a separate schema in Project TOML. There's no one top level schema in Project TOML. So we're really not talking about Project TOML. We're talking about the Buildpacks IO fields inside of Project TOML with their own separate API version.
I thought the project descriptor as a whole had a schema version.
With this
seems
new
fair.
model, the subtables have individual schemas.
So what happens if we want to move away from like reverse domain name structure?
We would have to move to something with divided schema. Sorry, Emily.
I remember, I'm just trying to remember on the issue, there was a question about whether we wanted the top level schema to also stand in for the build, or we kept two. I can't remember how we resolved it though.
Yeah, no, I thought like underscore has a API version, and that's how the overall file structure. Sorry, Terrence, if you know the answer, please.
Can't hear you.
Oh, sorry. Can you hear me now? No?
Yeah.
I originally proposed two, and then we decided we didn't want to deal with having to deal with the complexity of versioning two different things. And so then we voted to collapse it under one. I'm happy if we want to split that back out into two to support this mechanism, or not mechanism, but whatever this is. If that makes sense.
Mechanism, I think, fits well with two for the same reasons that two felt bad without this mechanism. It's like, oh, not only are we going to make platforms deal with API versions of this file, but we're going to make them deal with the build schema version as well. If we have, I think two fits better if we want to go this direction.
We're just gonna reverse all the decisions we actually made.
To me, it doesn't matter that much if it's one or two. The important thing, I think everybody would agree that the schema version, wherever it is in Project TOML, doesn't specify Salesforce's schema version, right? If you have a com.salesforce key in Project TOML, you're not going to put things in the Buildpack spec for a schema version of Project TOML that say, and this is how you interact with Salesforce in that schema version, right? That, like, I don't think anybody had that idea in their head. I don't think it matters if the Buildpacks IO field and the underscore field are versioned together separately in this conversation. It's just whether external tables for the platform are versioned separately from those two. So personally, I think that it's, Project TOML is getting kind of weird because it's like, this is trying to be something that's not, it's much wider scoped than the project, right? And that's why we have questions like, should there be one or two schema versions? Because if there's one schema version, then it's not really wider scope than the project. It's really a Buildpacks descriptor that we're trying to make something that's, more generic. If it's two, then it could be, but then I'm starting to wonder, like, is this something the project should specify, or is this something that we want to be, more generic than the project itself? Now we're moving project-specific fields into something where it really is generic. You could use this with Docker files, and it would make just as much sense.
Kenny, but a schema version for the top level file can have tables that are undefined or arbitrary, and then those subtables can choose to have or not have an API version within them, right? I'm not sure I agree that like putting a single API version means that like io.google is fixed at whatever we say it is.
But if you had a single API version at the top, right? I don't think anybody, I don't think you can assume that that API version applies to io.google, com.salesforce, com.vmware, right? Like, because those things would need to be specified in the description of the schema. And like, I think we would all push back on putting platform specific fields in the description, company specific fields in the description of the schema at the project level. So you can put it at the top and say it's at the top and it applies to the file, but nobody's going to agree that it should apply to any of the subfields of the file. So it really doesn't anyways, if that makes sense.
Well, I think what
Yeah,
it does, it thinks about like things as how they're compartmentalized, right? And that's what the top level schema version means to me. It's talking about how things are then organized on the subset, right? Where if you didn't, again, let's say that we change away from the reverse name into something else, that would be the way that we could trigger to say, okay, this now overall structure is different and this is how it works.
But that doesn't apply to this. The top level key wouldn't apply to the structure of com.vmware.
Right, yes.
No, but it just applies to the fact that you can't have com.vmware.
Right.
That we are accepting. I mean, if you read the spec that was merged in, right, like it says that all other tables that are reverse domain notation, including IO Buildpacks, right?
Yep. But then within one of those tables, you can have a custom schema version that describes that table. And that's what we're talking about here. So it's okay for a platform to read that field.
Yes, and so this is where I want to rebuttal, right? Like I feel like it's very little value if we're trying to like future-proof this to say that the platform could still read the file beforehand. And the reason for that is because then that means I still have to look at that top level schema version to determine whether I'm going to find the data the way that I expect it to be, or it could be in this next version format that I'm not aware of. So what I would expect and propose is that no matter what the life cycle is provided the project descriptor, and any additional, like again, those small sections or subsections, those could be provided in that platform API output as necessary. And that is the format that we read. So if the nested formats were to be placed differently, right, I would still be able to find them however I may need them, but only have to read the file once in one format.
I think if we're going to define the general structure of the file, that reverse domain name notation as part of the project descriptor format, then we should introduce even more schema versions. There should be one for the underscore. There should be one for each of the domains. Then we should not change the top level one, if that makes sense. And
Well,
then really
the way you phrase that is odd. Wait, the way you phrase that is odd because this is a discussion that went through RFC, was introduced to the spec, was merged, right? And but you're framing it like, if we do this, like I feel like we decided this, like so we're running out of time, so I want to try and get some kind of resolution. The thing that's important, I think, to Terrence and I is getting 0.2 out. And if we're going back on what we merged into the spec, that's fine, but I want to be really explicit about that. And like, let's go through the process of, reworking that. If we're not, then I think it's really about, are we, this discussion around like pushing into the life cycle. And like I said, I don't care if there's an IR or how life cycle does it or what, like, I think these are great ideas, but it doesn't really have any bearing on the schema of 0.2. So if we're going to do that, then I think the only question is, are we trying to do that before 0.2? And then that would be a separate discussion. So I think we should do that or something like that regardless. But I think we need to come to a decision on whether it's before 0.2 so we can get it out, or backing up a further step, are we uncertain about what we're shipping in 0.2? Those are the really important things to us, I think.
I think the only thing I heard was whether we want to have two different versions. But even that I would consider a slightly minor thing. Everything else sounded very additive. but I don't know if anybody else read it differently.
Are we concerned that 2.0 is going to go out and create a contract between a platform and fields like Buildpacks and Project Toml?
mean, we
1.0
already-
already does that.
We already
That
what's-
contract already exists.
So is there any reason to release 2 or to hold off on 0.2 for create that intermediary representation? Is there a compatibility issue caused by another version because they're pre 1.0?
It would be because if a platform, it would be about creating breaking changes. Like if someone went and updated this in their app, it would create breaking changes with other platforms. But also platforms can just hold off on pulling in O2 until we have this compatibility if they need that, right? Like with other specs, not everything that implements them updates on day one. So I think we could release it, but people would have to understand that if they change their project descriptor, it might not work everywhere that it currently works. That's
So
all.
we could really,
If
so we
everyone's
could
okay
really-
with that
doesn't
caveat,
currently
we can
work.
ship it. Parts of it do.
But it already currently
Yeah.
doesn't fully, parts of it do, okay, right, so I feel
Yeah.
like it's not a perfect
Those
world.
parts would stop working, right? That's the thing. It's not a huge deal, I think. I don't think a lot of people are using it. I think getting this right in the long term matters to me. But I don't think it matters. I don't think it's a huge deal for O2.
I just want to make sure the stuff.
To Emily's point for long term, that we're shipping stuff in 0.2 as well, that we're not gonna have to backpedal in like a 0.3. So as long as we can do the IR and other things without having to break the world in 0.2, I think that's important to get that right.
All right, we are over time, 3 minutes over. I did add an action item. I'll probably add a few more and assign some people to it. Feel free to say, I don't want to do this and, kick back on that. But yeah, otherwise, have an awesome day.